Okay, everybody. Welcome to Pre-Calculus. My name is Rush Mahaber. We are going to take a look at a couple things to get us started off. Now, today we're just going to start by talking about solving equations of all kinds. These should be prerequisite things that you understand before you even attempt a pre-calculus course, which is based off of these techniques. So if you don't really have them down, it's not really a good thing to start the course with. So, a couple things I want you to pay attention to. Let's just talk about a big picture. If you look at the entire realm of just equations, and there's really only thing you really need, and that is you could do whatever you want because it's an equation. You just got to remember to do it to both sides. So we're balancing things out. Now, remember, so that's the first thing. Do whatever you want, you want to do to both sides. And the second thing is that you got to have a general strategy. And the strategy is at the end of all this, we need to have our unknown variable x, y, z equal to something, right? So we're solving for x, and you can do whatever you want as long as you do it to both sides. So without further ado, let's get started. All right. So we've already talked about solving basic equations, or you should have already talked about solving basic equations that look like this. We call these linears. Why? Because they are degree 1, and they're degree 1 because the exponent on the variable is 1, or of all the variables. In this case, there's only one variable, one spot. And we'll talk about other degrees in a bit, but obviously all we have to do is just solve for x. So we'll subtract 4 off each side, and you'll notice I'll start to skip some of the preliminary steps, and then you get x equals 1/3. Okay, so pretty easy, right? So this is remedial. That's remedial. That's not what we're talking about anymore. What we're talking about is stuff that looks like this. So this is a different kind of equation, not really different kind, but you'll notice this, that when we start going up in degrees, we'll have other techniques, and a big technique. So for example, if I said solve this guy, solve x squared plus 4x plus 3 equals 0, we could do this fairly simply with just factoring. So if you remember, this is going to break up into two binomials. This is x, and you look at the back term and see what we could do to get this 4 here. And remember, it's guess and check, so that's a 3, that's a 1, and I think they're both pluses. And if you check it out, you'll see it does come out to that. And then by the zero product property, basically saying that if this times this gives a 0, then that means one of these two has to be 0. So it means x plus 1 equals 0, x plus 3 equals 0, and then you end up getting x equals -1 and x equals -3. It's fairly simple, and obviously with an equation you should be able to plug it in and always check, right? Now, let's go a little further. What if it doesn't factor, or you don't see the factor? So here's an example for you. X squared plus 4x plus 5. Now, if it was a -5, it would factor all day, but the +5 dampers things a bit. So what do we do? Well, what do we do? Well, I don't know if you guys remember this, but there is something that helps us solve equations that are degree 2. We call these equations called quadratic, right? And what we're going to need is the quadratic formula. I don't know if you guys remember, but the quadratic formula goes a little something like this, and that's x equals. So we're finding the solutions here. Negative b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c, all three of these are actually the coefficients inside of your quadratic equation. So in this case, A will be, if I can get my little taskbar back, boom. A will be 1, B will be B4, or positive 4. Make sure it's positive, and C would be 5. So it's just a matter of doing a little bit of plugging and chugging in here, and we'll be ready to rock and roll. So here we go. So we end up getting, in this case, -4 plus or minus the square root. 4 squared is 16, guys. You gotta. I always say that there is no time machine except for the one where you can do mental math in your head. So the better you are at calculating stuff, the better you are at saving time. Okay, we can all do mathematics, and I'm almost sure of it. We can all do mathematics, but we'd all, sorry about that, we'd all be able to do it a little bit better if we're able to compute stuff in our head. I guarantee you that. Okay, so that's how you save time, is having strong computational skills. I always feel like people people who can't do strong computational math use calculators too much. And they're there to help us when it gets really bad, but this stuff isn't bad. So -4 plus or minus. Anybody remember what 16 minus 20 is? You should say -4 to yourself. And then this should start ringing bells to you. This should start ringing bells to you. And you're probably saying to yourself, Rush, what do you mean ringing bells? Well, recall that the square root of -1 is I. Okay, because obviously we can't do square roots of negatives, and if you're looking for real solutions, you know, in most other courses they'll specify whether or not you want real or unreal solutions, right? Whatever you want, and if there are unreal or complex solutions, you'll state them in A plus BI form. Well, in 1800, it's already expected that when you're solving for all solutions. They don't have to state it. So, just understand that this is what this is going to simplify down to. So what does this end up becoming? Well, I'm going to do a little math here, and some mathematicians yell at me for doing this, but I feel like it's very, very clear. I broke the -4 into -1 times 4. And why so? Because that gives me -4 plus or minus. The square root of -1 will give me an I. The square root of 4 will give me a 2. And then that's divided by 2. And then obviously you should simplify this guy down. And this is what I'm going to do is I'm going to split the fraction up. So that leads me to understand that my solutions are this for this polynomial right here at the beginning. Okay, and yes, now there's a part where you have to analyze your solutions. So are these my solutions? Yes, they are. But if they ask me for real solutions, or if this is a problem that pertains to something in real life, obviously you can't have a real measure be imaginary numbers or complex numbers. So these are my solutions. But if they said state all real solutions, then my answer would not be this. It would say clearly no solutions. So please make sure you read your instructions. Very, very clear. All right, so that's basic polynomials, and the degrees of these can get higher and higher. I can give you a degree 3, a degree 4, a degree 5. But if you notice in other classes before here, all you've had were really just degree 2s because you didn't really have the muscle power yet to do all the other stuff. So let's continue with our review, and when we start talking about degree 3s and later on in the book, it'll be much more transparent what we're trying to do. Here's another type of equation, okay? We call these fraction equations or rational. Rational because ratio means fraction. Rational equations, okay? And what is a rational equation? That's exactly what I said. It's an equation with a fraction. So here's an example for you. Something that's not as clean. Let me give you this guy. He's not clean at all. 4 over x minus 1 plus 2 over x plus 1. And guys, I'm just letting you know, I'm going to try to keep each video to 20 minutes because it just gets a bit long and you don't want to hear me talk forever. So, alright, here we go. Remember, you could do whatever you want as long as you do it to both sides. So we're going to do it to both sides, right? So what do I want to do here? Well, first things first, what do I want to do? Well, I can't solve for x if it's in a denominator, so I need two clear fractions. That's its bottom line. It's an equation, so I can do whatever I want while I do to both sides. So how am I going to clear fractions? Is by acquiring the LCD. This is the exact same way I would add fractions. But remember, I could do whatever I want while I do to both sides. So once I get the LCD, instead of putting missing factors in and finding a common denominator, I'm just going to multiply through by that common denominator, and that thing is going to get me what I need. So here we go. I'm going to start by first things first, and I always tell everybody to do this. Put those parentheses in here. It actually simplifies the problem quite a bit, or makes it easier to see. Maybe it's probably the thing. It doesn't simplify it at all, as we have not done anything mathematical. All right, let's keep moving. And you should notice something about the denominator. It's the difference of, and everybody should probably have said squares, meaning that it factors into x plus something, x minus something. So here we go. And don't forget our little transparent bubbles that we have put in. So boom, 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 boom. So here we go. What is the LCD? It is the number that all three of these denominators will go into. So check this out. This is a very complex thing in a sense, right? So x minus 1 and x plus 1, this entire thing will go into that. Boom. But x plus 1 will go into that. Boom. And x minus 1 will go into that. Boom. We want to avoid just multiplying everything together. Because if we multiply everything together, we might pick up extra factors. Because this is my least common denominator. If we multiply everything together, we'd get a common denominator, but it won't be the least. So let's move on. And obviously, I'd encourage you to go back and watch the videos about regular algebra to show how we find least common denominator with numbers if this isn't clear. So let's move on. So what we're going to do is we're going to multiply this by. Now I always say showing your work is the biggest part of mathematics. So watch what I do here. You're probably saying, Rush, why in the world did you put all this space in here? Is that really necessary for this problem? Well, it depends. In order to shoot a good jump shot, if you follow basketball, you gotta make sure your hips are square, your legs are square, your knees are slightly bent, your calves are engaged, your shoulders are square, your elbow is bent. You make a T with your hands before you release a jump shot. This is all the things that goes into it. Now, if you don't follow basketball, I'm sorry, but my point is a good setup is important for success. Is it possible for you to get it right if you don't set up? Yes. Is it probable that you'll get it right? Probably not, okay? So it's possible, but not probable. All right, so now, when I do all this, now what do you see? Well, you start seeing stuff could factor, right? Let me highlight some stuff that's going to go away. And this is what I don't like. I don't like when people just start hacking this legendary problem, so I'm going to highlight. This will go away with this. This will go away with this. And this entire denominator will go away with this entire factor. So what does that end up leaving us? That leaves us the 4 times the x minus 1, and I'll write it in green just to make it clear why it's there. It's left over. And then we have plus 2 times the x minus 1 again, x minus 1. And then we have just 35. Now, this is an easy rinky-dink problem. So go. Here we go. And I'm going to speed through it. 6x plus 4 minus 2 is 2 equals 35. Now, you're probably saying, Rush, how did I do that? I simplified very quickly. This is where you save time, right here. If you could do this little rinky-dink algebra in your head, that's less you got to write, which is a good thing. Now, if you can't, then write it out. You'll end up with the exact same answer. Here's 33. X equals 33 over 6, which simplifies, not reduces, simplifies to 11 over 2. Now, I'm already going to tell you, if I didn't jack up on my math, this is my answer, and I don't have to check it, even though you should check everything. So let me ask you a question. What two numbers, sidebar, and here's your brain, what two numbers should you already have in your head that say, if I get these in my answer, it would not work out? And the answer should have been x cannot equal 1 and x cannot equal negative 1, because those would be the things that made your denominator 0 from the get-go. So you always want to check and see what your domain restrictions are on a problem, just to make your life a little easier, okay, later on. The more things we can be doing in our head does make our life quite a bit easier, okay? So that's a rational equation. I don't care how complex it is. If the common denominator was so involved that we had to do a ton of extra work, then to get our LCD, and we will do that. And if I had to put 20 of these denominators in on 20 things across the problem, I would, but I would end up getting the correct answer. All right, let's move on. Let's talk about another kind of equation. This is my personal favorite, to be honest with you, because I think it has more physical attributes than anything else out there. And that is a rational, not rational, excuse me, absolute value equations. Okay, so let's talk about what an absolute value is. Okay, absolute, if I can spell, value equation is. Well, an absolute value, as you guys probably already know, is the distance away from 0. So when we solve for these guys, we need to make sure, one, that you don't make copy errors. Two, you don't make sign errors, because if you jack this up, it's going to be bad. And like anything else in mathematics, I need to isolate for absolute values. Now, a common mistake for people is they like to multiply things in. Absolute value is not a parentheses, so you got to make sure you isolate for them, okay? And the moral of the story, if you remember back in the day when you first learned absolute values, they told you that by definition, the absolute value is the distance from 0. Right? And here's the thing, if you go from 0, if you go 2 steps to the right, you end up at 2 from the number line, right? And if you go 2 steps to the left, and you end up at 2 steps to the left, and you end up at negative 2. So notice it has nothing to do with the number. It has everything to do with how far we're going from that origin, okay? So, and it can get more complex within mathematics, because math just, for some reason, we apply them to other things, and it gets much more interesting. All right, so let's keep it moving here. So first things first, we're going to do is you have to isolate for the absolute value. I don't care how complex the problem is. So I'm going to isolate. Notice that I wrote my 3x minus 1 in red. You should not be touching that until it's isolated for. Okay, and I'm going to keep writing it in red so you know it's bad to touch it. I don't care what it is out there. Let's isolate for it. This will give me negative 7. Be careful, be careful. It's always tough when you switching sides. All right, so we get absolute value of stuff equals 7. and here's 3x minus 1. Now, how are you to think about this? Well, I know everyone always says, well, make this equal to 7 and negative 7, but it's difficult. If this is a negative 7, guys, absolute values are our distances. So let me ask you a question. Can a distance be negative? That makes no sense. If I say take negative 2 steps, what does that mean? Like, do you go backwards 2 steps? No, you just took 2 steps backwards. Like, that's not a negative number. You're not taking away anything. You don't owe me anything. So, moral of the story is that you really have to make sure. You have to make sure that the absolute value is isolated for, and that you actually are thinking about what's going on here. Okay, so if it was negative, the answer would have been no solution, and we're done. Okay, anytime we compare a distance to a negative number, it's going to be real quick. But here, let me draw you a picture so you understand what's going on. Here is where 0 lives. Now, let's be careful. I want all the distances that are equal to 7 steps away from 0. So if I go 7 steps to the right, what number do I land at? Correct, I end up at 7, right? Now note something. This 7 and this 7 are not the same 7s. No, not at all. I know you guys are probably looking at me, like, what do you mean it's not the same 7? It's not the same 7. This 7, wanted that to be red. This 7 and this 7 is this 7. It's a distance. Distances have a start point and a stop point. So this distance is 7, and it just so happens that 7 lives here. 7 lives here, okay? Let's go 7 steps to the right. Okay, so if I go 7 steps to the right, who lives there? You're absolutely correct. It's negative 7. So what's the punchline between all of this? Now I need to figure out when is 3x minus 7 at this residence, and when is 3x minus 7 at this residence, because when he's at those two residences, then he has a distance of 7. Done and done. That's all it is to it. Don't make it more than that. So now that's when we end up saying 3x minus 1 equals negative 7, 3x minus 1 equals 7. And now it's a really easy problem. I'm going to skip the work. X equals, because I want to now harvest my time here, equals subtract, add this over, gives you negative 6 divided by 3 should give you a negative 2. And then likewise, this gives me 8 over 3. So x equals 8 over 3. And likewise, this guy works. Okay, so fairly simple stuff. Fairly simple. All right. I think we're going to go a little bit over the 20-minute mark, guys. I'm sorry. There's two other types of equations that are absolutely essential we talk about. The other one is solving radical equations. Now, people always say, what are radicals? Those are like your roots, okay? They're called radicals. Radical equations. All right. So the whole moral of the story is you got to remember that to undo a radical equation, you isolate for it, right? Like anything else. But sometimes you'll have more than one radical. So like right here, we have more than one radical. So I'm going to isolate for this creature and then kill it. How do I kill it? Well, how do I undo a square root? Well, I square both sides. So here we go. I try to minimize the amount of negatives I have, so I'm going to add this thing over. Gives me square root of 2x plus 3 equals 1 plus square root of x plus 1. All right, so now this is where you have to be careful. Be careful. To undo a square root, I need to square it. Whatever I do to one side, I'm going to do to the other side. Now, this is the only way to kill it. If I had squared it right here, it would have terminated the outside ones, but it would have popped up somewhere else, which is not what we want. This is why we need to isolate for it to take care of it. Okay, square this out, gives you 1 plus. Now, how am I getting this? Once again, if you don't have the mental math skills to do what I'm getting ready to do, you need to go to the side and then work some magic. And what do I mean by work some magic? Here's my think bubble, and here's my brain. Think bubble meaning scrap paper. Oop, what did I do wrong? 1 plus square root of x plus 1 times 1 plus square root of x plus 1. And this gives me 1 plus 1 of those, plus 1 of those, and plus another one squared, which means I just have this, because square root of x times square root of x is just square root of x squared, which is just x. So if you notice the two roots, they complete each other, and they make us a whole, if you will, whole x. Now, this gives me 2, adding same stuff, plus 2 of those, adding same stuff, plus x. All right, so if you notice, by doing this, 2 plus 2 square root of x plus 1 plus x. Notice that we are officially down to an equation with one radical. Great. What do you think we got to do to kill this one now? You're right. Isolate, do it again. Here we go. So I'm going to subtract x off. Right? I'm not going to write it down. You guys can see it. I'm going to subtract x off. This will give me a regular old x on this side. I'm going to subtract 2 over. Let's give me a plus 1 on this side. And then I'm left with this. Now, a lot of people say to divide by 2. Actually, guys, I'm going to be honest with you. I only divide by things that are helpful. Like, dividing by 2 is going to create me a fraction, which sucks, okay? Because I'm going to have to deal with a fraction later on. If you notice, when we covered fractional equations, we ended up clearing it out. So what am I going to do? I'm not going to divide by 2. I would have divided by 2 if it looked like this, though. If we were 2 times 4, right, if it looked like this, 2, I would have definitely divided by 2, because 2 would simplify with this stuff over here. Now, will this stuff actually get me, will it get me what I need? No, if I like this stuff it would simplify, but if I did it before, I'm getting jumbled, guys, sorry. If I did it before, it would not have given me what I need. So I'm going to leave it just like that. So what am I going to do? I'm just going to square it as is. Square it as is. And can I do this? Yes, because it's an equation. I can do whatever I want as long as I do it to both sides. So this gives me x squared plus 2x plus 1. This gives me, be careful, 2 squared is 4. This gives me, so that's that, times x plus 1. Now let's multiply it through it. And then, oh look, I wonder if we could solve this. Yes. Well, I might need quadratic. Sometimes you might need to, because look at you're ending up with a polynomial here. X squared plus, minus 2x. Careful, careful. Minus 2x. Minus 3. Oh, thank goodness. Factors. X minus 3. X plus 1. So x equals 3, skipping the zero product property because I think you guys noticed that each one of these is equal to 0. And then solve. We get these two answers. Now, are we done? No. No, no, no. Remember your second domain restriction. What do you mean, Rush? You're always talking about domain. These are things that'll break my stuff, man. You got to be careful. If you have a root that's even, like square root of, I don't know, call this thing rad because it's called a radican thing on the inside. If the radican can't be negative, if you want it to be a real function, so it has to be always positive. So I plug this in and it breaks it, so check this out. Or it just might not check, you never know. -1, let's plug it in. -1 plus 1 is 0. Okay, so this is 0, done. -1 plus 2 times 2 is, what is -1 times 2? That's -2 plus 3 is 1, so that's going to be 1 minus 0, which ends up giving me 1. Okay, so this one checks out. Okay, let's do the same thing with 3. 3 plus 1 is 4, square root of 4 is 2. 3 times 2 is 6, plus 3 is 9. That's going to be 3 minus 2 is 1. Oh, they both check out. Very nice. Okay, see how easy that is, guys? And now, if I didn't have those mental math skills, then I'd have to write all this down, and it would have sucked 30 seconds out of my work, which is terrible. All right, I know we're getting a little long here, guys, so I'm going to talk about the next kind of equation, and this is also a big, big one, and these are things that are quadratic-like. Quadratic-like. What do you mean by quadratic-like, not quadratic? Well, x to the 4th minus 5x squared plus 4, what degree is that? Clearly it's degree 4, which means that it's not quadratic. So what do we do? Well, we're going to assign a dummy variable. And you'll notice we'll do this all throughout mathematics to make things formatable. Now, some of you guys are good enough to factor this the way it is. And if you are, kudos. But if you're not, you subbing something or creating this dummy variable u makes our life a heck of a lot easier. And I'll show you what we do with this. If you notice the stuff that has your variables attached, we have x to the 4th and x squared. Notice something here. When we have a quadratic, and this is my thought process, I have, I don't know, 2x squared, the 2 is random, I'm just throwing it in there, plus x plus 4 equals 0, right? What makes it quadratic is one of these guys are the square of the other one. Okay, and let me not use x. I'm going to actually use u. Okay, so notice one guy, and then you have this other thing that is u squared. That's what makes it a quadratic, is that the other guy is the square of the previous. Well, check out these two. Do you notice anything? Well, check this out. So I want you guys to guess a u. So we got two choices for u, either x to the 4th or x squared. So let's let u equal x to the 4th. Then that means there should be a u and a u squared. So if I squared my choice, this is my check, if you will, I end up getting x to the 4th squared. What do I do when I have an exponent to an exponent? You better have said multiply. This is at the stage of the game where it has to be quick. Okay, you get x to the 8th. Is that in here anywhere? Absolutely not. Therefore, bad you. You screwed up. But it's okay because we can choose the other guy. And does this always work? No, this is all about methods. These are tools to keep in your toolbox just in case it gets busted. Okay, and stuff to use. And sometimes it won't work and we have to use other stuff. Like when we get later on in the book, I'll show you other cool little stuff like the factor property and rational root theorem, things that'll get to help you break stuff like this apart. So we have this. One have x1, x1, this gives me x to the 4th. So notice x to the 4th lives here. X squared lives there. So anywhere I see a u squared, x to the 4th, I'll put a u squared. And then we see a x squared, I'm going to put a u. So this becomes u squared minus 5u plus 4. And now it's very clear what everything is. So now solve, and this is cool because this is factorable, thank goodness. Minus 4 minus 1, so u equals 4 and u equals 1. And don't be that student that automatically says, whew, I'm done. No, I'm not solving for u. I introduced u. What am I solving for? Sorry, guys. I'm solving for x's. U is x squared. So this ends up being x squared equals 4. X squared equals 4. I still got to back substitute what u was so I can actually solve for this. So now that I solve, I get x equals plus or minus 2 and x equals plus or minus 1. How so? Square root both sides. Okay, so you end up with 4 solutions. Do they all 4 of these work? Yes. Why am I going to say yes? Because I don't have time to check them. If you check them, you'll see that they work. Now, will they always work? No, and you must be careful. Must be careful. But these are the only types, and obviously they can get more difficult as time goes on. You just have to practice, 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 practice. There's tons of stuff that webassign has assigned, and there's tons of stuff on the web you can actually seek out. But guys, I look forward to our journey. And once again, in order to do anything or go anywhere you haven't been, you're going to have to do something you have never done before, guys. All right, so increase your level of grind, work hard. If you got any questions, send me an email. All right, talk to you later. Bye.